This allows particulate and heavy organics to move freely through the filter media. This porous structure is similar to that found in the soil, which the filter is intended to model. This accounts for the close agreement between the steel filter and soil column results.
Once we had developed the modified method and were satisfied with the liquid-solid separations we were getting with the new stainless steel filter, we felt it necessary to evaluate the full modified method. To do this, we conducted the modified method 1311 in triplicate on the same wastes that we used for the soil column experiments. By comparing the waste constituents released into the filtrate and extract of the modified method with those released into the soil in the soil column experiments, we measured the accuracy of the new procedure. In addition, we conducted the existing method 1311 in triplicate to see how much we had improved on the results of that method with the modified method. Finally, the triplicate results from the modified method were used to calculate the new procedure's single laboratory precision.
Jeff Keever of RTI will now demonstrate the modified method 1311. This demonstration concentrates on the steps of the procedure that are different when the steel filter is used. The steel filter is to be used only for wastes that cannot be filtered through the glass fiber filter. Prior to use, the steel filters must be boiled in reagent water or otherwise de-aired and stored in reagent water until used. As with the glass fiber filter, the steel filter is mounted in the filtration device. However, because the steel filter is rigid, the support screen used for the glass fiber filter is not required. The filtration device is then assembled, the waste added, and pressure applied as in the existing method 1311. The initial filtrate is collected, measured, and stored for later analysis. The filtration device is then disassembled and the filtered solids are carefully scraped from the steel filter into a 2-liter glass extraction bottle. It is important to make this transfer as quantitative as possible. Once the solids have been removed, the steel filter is placed into a clean glass container and covered with 100 milliliters of the same extraction fluid to be used in extracting the waste solids. The container is then covered and the filter is put aside to be reused later. The appropriate amount of extraction fluid is added to the bottle containing the waste solids. As in the original method, the bottle is then placed into a rotary extractor and allowed to agitate for 18 hours. Following the 18-hour extraction, the original steel filter is placed into the filtration device. The liquid used to store the filter is added to the filtration device along with the extracted solids and extraction fluid. The extract is then filtered and analyzed as in the existing method 1311. The viewer is cautioned to include the 100 milliliters of extraction fluid used to store the filter when calculating method 1311 final analyte concentrations.
We have several interesting conclusions and quite a bit of very useful information generated from this project. First of all, by conducting our soil column experiments, we've provided some new information on how oily wastes actually move in soils and how the waste constituents may be released to contaminate groundwater if they're improperly disposed. Second, by comparing the results of these column experiments with the existing method 1311, we demonstrated that that procedure is not adequate for oily wastes and other difficult to filter wastes. Third, we developed a new procedure by modifying the filtration step of the old procedure that we feel is adequate and accurate, and we demonstrated its accuracy and precision by evaluating it again, comparing it with the column results.
Because the current method 1311 is adequate for filterable wastes, and because the stainless steel filters are relatively expensive, the modified method retains the glass fiber filter for wastes that filter satisfactorily through it. The steel filter is only to be used if clogging of the glass fiber filter is encountered. To recap, the current method 1311 is not accurate for certain difficult-to-filter wastes. Porous media stainless steel filters improve filtration efficiencies. The modified method 1311 is adequately precise and more accurately estimates release potential of oily and other difficult-to-filter wastes. For further information, contact Methods Section, Technical Assessment Branch, Office of Solid Waste, OS 331, U.S. Environmental Protection Agency, Washington, D.C. 20460. Area code 202-382-4761.